All right, guys, good morning. Today we're going to talk about properties of parallelograms. So first page is going to be notes, and then second page we'll do three examples of solving for angles and side lengths. Actually, at the bottom of the first page, we'll show a few different ways to prove if a shape is a parallelogram. So first things, couple properties. You guys can pause and get these four things written down, and then I'll go ahead and talk about them. So first thing, opposite sides will be parallel. So opposites. They won't always have markings. Sometimes in the directions they'll just tell you that they're parallel. So I'll put markings on here just to indicate. We could do this with arrows, little triangles. So opposite sides are parallel. The other thing is that opposite sides will be congruent. So the top and bottom are congruent, left and right are congruent. Opposite angles are congruent. Opposite angles. So, for example, this angle will be congruent to this angle, and this angle here will be congruent to this angle here. You know, I should probably label. Let's call this A, B, C, D. So opposite angles are congruent. The other one we have consecutive angles are supplementary. So consecutive means two in a row. So if you start with one angle, either go around clockwise or counterclockwise, and the very next one you get to is the consecutive angle. So for example, A and B are consecutive. A and D are consecutive. B and C are consecutive, B and A. C and D are consecutive, C and B. D and A are consecutive, D and C are consecutive. Okay, so pick any pair of those that we just talked about, and there will be a supplementary relationship. So, for example, if I knew that angle A was 60 degrees, if that were true, I would know that angle B would be 180 minus that, which is 120 degrees. Okay, let's look at that same relationship with B and C. If B is 120, C is a consecutive angle with that, so 180 minus 120 gets me 60 degrees. And we can see that by doing that, I also find that A and C are congruent, which I knew was going to be the case anyways. Let's see, B and D are opposite, so D has to also be 120. And then you can see that D and C, as a result of that, are supplementary. D and A are also supplementary. Okay. Two skills that we already know that we learned either earlier this week or in the past: slope formula, distance formula. Remember, x1, y1, and x2, y2 are the 2 points or two of the points that are provided. Okay, so what I want to do is use slope to determine whether the given vertices form a parallelogram. So here's what I want to do. Let's sketch. You know what? Let's do this. I have the coordinates. So let me sketch here. -1. What's the largest x value? 5. 1, 2, 3, 4. Highest y value is 5. And lowest y value, I don't think I need any negatives. Okay. So let's plot this in blue. So I have t is -1, 0. U is 0, 5. V is 3, 3. W is 2, 1. And let's connect these. Okay, and what I want to do is find the slopes. Now, look, guys, I think we can tell from looking at this shape that this is definitely not a parallelogram. Maybe WV and TU are parallel, but clearly UV and TW are not parallel, just from the eye test. But never trust your eye. Always find the slopes. Okay, always calculate. So What I'm going to do is find the slope, and I won't show all the work here. I'll pause it and speed up in the interest of time, but let's find the slope of UV. So my slope is going to equal, so I'm doing U and V. So let's do 5 minus 3 over 0 minus 3 gets me 2 over negative 3, or negative 2/3. Now let's check TW. I like to check two of them that are across from each other so you can see right away if there's a chance of it being a parallelogram. So TW, so now let's check T and W. So 0 minus 1 over negative 1 minus 2, and we get negative 1 over negative 3, which becomes positive 1/3. So UV and TW are not parallel. So that tells me that this is not a parallelogram. Okay, so what I would have needed to do is proven that these two were parallel, and if they were, then I would have had to prove that these two were parallel. Okay, now I'm going to erase those marks because that did not happen. Okay, but that's the idea. Okay, next, use the distance formula. So distance formula talks about side lengths. I need to prove this number 2 here, that opposite sides are congruent. Okay, so distance formula to prove that this is a parallel, or if this is a parallelogram or not. Let's see, these are all in quadrant 1, I believe, so that's kind of nice. Quadrant 1, my largest x is going to be 7. Largest y is going to be 5. And let's go ahead and plot. G is 1, 2. H is 2, 5. I is 7, 4. J is 6, 1. So this could be, my sketch might be a little off, but this looks like it could be a parallelogram. Okay, so I want to check the distance. So I'll show the work for one, then I'll pause it, finish the work, and then show it again. So make sure you're good with practicing distance. So let's check GH. Okay, so G and H. So the GH distance equals square root of 1 minus 2 squared plus 2 minus 5 squared. This is going to give me 1 minus 2 is negative 1. Square that, that's 1. 2 minus 5 is negative 3. Square that, and we get 9. By the way, when you square something on the calculator, if it's a negative, make sure you put it in parentheses. When you square something, it will always result in a positive number, because it's either going to be a negative times itself or a positive times itself. Okay, so just double check that. So this is the square root of 10, my distance. Okay, so I'll complete the work, and then I'll show the answers for the other 3 sides. You go ahead and do that work by yourself. So go ahead and pause. Okay, so hopefully you were able to see we proved that HI and GJ were congruent, and GH and IJ were congruent. That is enough to prove that this is a parallelogram. Okay, so if you can prove that opposite sides are congruent, you know it's a parallelogram, and you know that 1, 3, and 4 are also true. All those characteristics will be true. So you don't have to prove all of them. Okay, you just have to prove the opposite sides are congruent or opposite sides are parallel. Okay, so now let's do a couple practice problems. So this is a little tough to see, but let's put this 15x plus 10 is for angle W, not for Z. It's kind of tough because it's crowded here, and angle X here. So what I want to do is assume that these are all parallelograms. So all are parallelograms. So I want to find the measure of angle W. Well, I know that these two angles, X and W, will have a supplementary relationship. So the measure of angle X plus the measure of angle W have to equal 180 degrees. Okay, well, that means 6x plus 2 plus 15x plus 10 has to equal 180, and I can solve from there. So I get 21x plus 12 equals 180. Subtract 12 from each side. And then I divide by 21. Let me check. And I get x is equal to 8. Now keep in mind, I'm not asking for x. I'm asking for the measure of angle W. So let's plug that in. 15 times that x value plus 10 gets me 130 degrees. Okay, so we could check this. What should x be? Angle x should equal 50 degrees, right? 6 times 8 is 48 plus 2. That does give me 50. Nice. Okay, now we're talking about side lengths. Okay, side lengths. Opposite sides should be congruent. So 2x minus 1 should equal x plus 3. So I get that x equals 4. I want to find EF. That's this side length here. So 2 times 4 minus 1 gets me 7. Okay, we can check this side too. Plug in 4, 4 plus 3. Okay, that gives me 7 as well. So I know I'm right. Okay, last one. Measure of angle x. So this is what I'm looking for here. Ooh, this is interesting. I don't know anything about x, but let's always start with what we have, right? That's the only place I can start. I know that angle W is 8x plus 11. Angle Y is 10x minus 3. Those are opposite. They have to be equal to each other. They're congruent. So 8x plus 11 has got to equal 10x minus 3. Let's get 8x over there. So I get 11 equals 2x minus 3. 2x equals 14. X equals 7. So each of these angles, let's see, 8 times 7 is 56 plus 11, 67 degrees. Hopefully this works out as well for angle Y. 10 times 7 is 70 minus 3. That gets me 67 degrees. Okay, so what do I know about angle W and angle X? Well, they should be supplementary, right? So I can say 67 plus X, shouldn't use X, I already used X down here, right? Plus the measure of angle X, we'll say that, equals 180. The measure of angle X, after I subtract 67, gets me 113 degrees. Okay, so those are the types of problems that you're going to have to do, and then you'll also have to prove using one of the two methods that we did on the previous page. So check out the homework, email me if you have any questions, and we will talk soon. Thanks, guys.